Nowadays, we are moving towards a more autonomous world, where devices are getting connected to and communicating each other over the internet. Devices ranging from sensors to GPS car trackers and drones are now sending gathered information to the user or service provider over low-power wide area networks. These networks are designed to have a long connectivity range with low bandwidth and low power consumption, so that devices far from base stations can communicate and send data for a long time. In this video, we will show how simple testing OTA, TRP, TIS and Throughput for NB-IoT and LTE-M devices is when using EMITE test systems. Welcome to EMITE MIMO OTA test systems. For wireless IoT OTA testing, we will use our E500 medium-sized reverberation chamber with a control PC running our MIMO Analyzer graphic user interface software. The computer is connected to the chamber by a USB cable, and a Ritsu MT8821C E-Node-B connected to E500 front panel using RF cables and controlled through either an Ethernet connection to the control PC or a GPIB connection to the back panel of the chamber. Other alternatives like Roden Swartz CMW500 are also possible. Once everything is connected, the test system is ready to be used. Run the MIMO Analyzer GUI software and select the active MIMO OTA measurements main window. Select the LTE-M standard and set the specific band and channel to be tested. Next, click on the figure of merit to be added to the test batch, TRP in our example. This can be repeated for any other figure of merit, band or channel. Once done, click on Run to proceed. The test system will be initialized and auxiliary equipment properly configured. Tests will be performed in a fully automated manner using the set sequence. Place the wireless IoT device on the turntable inside the chamber with a test SIM card and connect it to the power supply on the turntable if needed. The device will get attached to the test network within seconds. Once the device is connected, click on Run to start the batch of OTA tests. A DUT attachment window will pop up for the first and only time. During the measurements, both the turntable and the steerers move in order to improve repeatability. After finishing a test and a warming up period, the test system will automatically start the next test in the batch. The video shows an automatic change from TRP to TIS. Handover, call drop and network attachment are automatically controlled by a smart GUI software routines, so that different figure of merit, bands and standards can be placed on the same batch. For determining maximum copying loss and other wireless IoT figure of merits, Throughput wireless IoT OTA tests can also be run using EMITE OTA test systems. Again, enter the active MIMO OTA main window. Single tests or batches in which individual tests can be individually configured can also be saved and loaded as pre-configured setup files. When your OTA wireless IoT test batch is ready, Throughput in this example, simply click on Run to initialize the test system and configure the auxiliary equipment. As before, place the DUT on the turntable inside the chamber with a SIM card and connect it to the power supply on the turntable if needed. The device will get attached to the test network within seconds. Once the wireless IoT device is connected to the test network, click on Run to start your throughput measurement. Real-time monitoring of the test partial results are visible on your screen. As more test samples are collected, The final result is also captured and displayed as the average value of the statistical ensemble. The drop in throughput response determines the device's sensitivity, and it is used to determine the different coverage areas. The first and only existing standard for testing wireless IoT over the air, published by CTIA, uses EMITE reverberation chambers as an example of testing system worldwide capable of providing a useful response to your wireless IoT testing needs. The small footprint I-series reverberation chambers allows for testing devices up to 15 centimeters and 5 kilograms, which is particularly suitable for IoT modules and small devices. The versatile E-series reverberation chambers allow for testing devices up to 50 centimeters and 50 kilograms in weight, and can be also used for passive MIMO, SISO and MIMO OTA, BDT OTA, and time domain testing, including WLAN TCP UDP throughput evaluation. The large F-series reverberation chambers allow for testing devices up to 2 meters and 500 kilograms, and it is capable of testing what the I and the E-series systems can test, and also heavy and large form factor devices such as refrigerators, trash compactors, large TV sets, robotic systems, drones, car cockpits, among many others. Testing wireless IoT devices and modules over the air has never been so easy. Check out our white papers and technical specification at our webpage or YouTube channel and start designing your future with EMITE test systems. Your IoT testing wishes made true.